All right, so now that we've gotten our first kind of introduction to exponential functions, how to graph them, what things we can tell from the graph, we're going to kind of incorporate everybody's favorite thing, exponents, to talk about exponential functions, specifically properties of exponents. So we're given this function, y equals 2 to the x plus 2 power. So that's not something that we really know how to graph just yet. So we want to kind of use these properties that we know to be able to put it in the f of x equals a times b to the x form. So the first thing, we're adding exponents here. And if you remember when we were talking about exponents, when you're adding, that means that you are multiplying two things with exponents together. So we're going to kind of do the opposite of when we were combining things. So we're going to rewrite this as 2 to the x times 2 squared. Because if we were to recombine those, we would add those two things together to give us that original. And then we want to see if there's anything we can simplify here. And we can simplify 2 squared to 4. And then we just want to rewrite it. We can switch the order because the commutative property. We can switch the order to 4 times 2 to the x. And that's in the form a times b to the x. So let's practice graphing this. So that 4 is our y-intercept. So we want to start at 4. And that 2 tells me that I'm going to double my y value each time I move. So when I move, 4 times 2 would be 8. And then if I move again, I'd be all the way up here somewhere at 16. So to get a couple more points on the graph so we can be as accurate as possible, we're going to move the other way. So we want to do the opposite. So the opposite of multiply by 2 would be divide by 2 or multiply by a half. So from 4, we'd go to 2, and then 1, and then half, and so on. So if we want to sketch that graph as best we can, that's what it would look like. So still increasing similar, but we kind of had to do a little bit more work than just given that equation in that first form. All right, let's look at another one. Remember, we're going to be using those property of exponents. So this has 3 to the negative x power. And when we talked about exponents, we said that we could never have a negative exponent. And there was a rule. If we had a negative exponent, we could take the entire thing and we could move it to the denominator. So we have 3 to the x power, and we change that negative x to a positive x. This is actually the same thing as 1/3 to the x power. And the reason why is 1 to any power is just going to be itself. So it technically doesn't need that exponent. But we want to rewrite it because remember, we want it in the a times b to the x form. And the only thing we're missing is that coefficient. And remember, if there isn't a coefficient, we're just going to assume that it is 1. So let's try and graph this. Our y-intercept is at 1. And we're going to take a third. So 1 times a third would be about a third. And it looks like we're going to get closer and closer to 0 on this side. So let's go to the other side. Dividing by 1/3 is the same thing as that multiplying by 3. So we're going to go from 1 to 3. 3 times 3 would be 9. 9 times 3 would be all the way up at 27. And it would look just like this. All right. So we're going to look at a few more. All right. The next one we'll look at says y equals 2 to the x minus 3. So it's similar to the one before. Instead of plus a number, it has subtracting a number. So we're still talking about the rules of exponents. So if we wanted to separate these, we would have 2 to the x times 2 to the negative 3. Because if we added those two things together, we would get x plus negative 3, which would also be minus 3. And remember, I said we cannot have negative exponents. So we could change that 2 to the negative 3, multiplication symbol, to 1 over 2 to the positive 3. And there's actually a little bit more we can do. Remember, 2 to the positive 3 is as 1 over 2 times 2 times 2, and that would be 8. So 2 to the x times 1/8. And if we want to be really specific, let's rewrite that with the coefficient first, 1/8 times that 2 to the x power. And this one's a little bit more difficult to graph just because we're starting at an 8. And an 8 times 2 is going to be a 4th. a full half. A half times 2 is 1, then 2, then 4, then 8, and then all the way up here at 16. So that beginning part was a little bit more difficult to graph. Oops, sorry, I was not supposed to cross 0 there. But it still does look like that exponential function. Just the curve of that exponential starts right over here. All right, and let's look at the last problem for this section. So we're going to talk about this specific function. It says -3 times 2 to the x has a y-intercept of what? So which of these two values is going to give us a y-intercept? Well, that is going to be our y-intercept 0, -3. It's that coefficient. And is the graph increasing or decreasing? Well, we don't have to be very specific, but let's make a little sketch. If we're starting at -3, and each time which is about down here, each time we are going to double that. So from -3, doubling that would go to -6. We go to -12. We're eventually going to keep going down, down, and down, and that's actually going to be decreasing. Although we're multiplying by a positive number 2, we're multiplying starting with a negative. So we're going to get more and more negative each time. And then this next part is asking, when is it decreasing? And it's decreasing on the right-hand side, and that's as your x value increases. And then this one is asking, where is it approaching 0? It's approaching 0 towards the left, and that's when our x's are going down, our x's are decreasing. Okay, and then this last question is asking, which of the following, when we simplify, will I get 8 times 2 to the x power? So let's look at this first one. If we were to simplify this first one, remember when we have a power to a power, we want to multiply those. That would be 2 to the 3x. That is not going to simplify to that 8 times 2 to the x. Same thing with this one, 2 to the 4th times x is not going to be the same because you can't combine that coefficient with that value to the x power. This third one, let's rewrite this, 2 to the x times 2 to the third. Remember, since we're adding those exponents, we're actually going to be multiplying. 2 to the third is 2 times 2, which is 4, times 2, which is 8. That would give me 8 times 2 to the x, which is the same. So the third one would be correct. Oops, sorry. It's hard to write on the screen. The fourth one, since I have that 2 to 2x in that numerator, that is not going to be the same. So we're going to say that that one is wrong. So let's look at this last one. It says 4 times 2 to the x plus 1. Let's go ahead and separate this out. So 4 times 2 to the x times 2 to the 1. 2 to the 1 is just 2, and we can multiply that 4 times that 2 to get 8 times 2 to the x power. So that last one is going to end up being correct. All right, that's all for this section. Again, please let me know on reminder email if you have any questions. Bye, guys.